In this example, the point P is marked at -2, 3 over in quadrant 2 in the coordinate axes below. And in part A, we want to give the coordinates of the point, which is symmetric to P about the x-axis. And so when we say that something is symmetric about the x-axis, this means we're going to take the reflection of the point P over the x-axis, over the horizontal axis, and look at its mirror image on the other side of the x-axis. So that would be down here at -2, -3. We'll mark this point in black, and we're going to take the reflection over and across the x-axis, and that puts me down here at a point I'll mark in black, and the coordinates of this point, the x-coordinate is the same, it's -2. Now the y-coordinate, since we've reflected across that axis, has now changed signs. So notice that when we take the point which is symmetric across the x-axis, the point P, which was at -2, 3, has moved to -2, -3. And this point has the same x-coordinate, but the y-coordinate changes signs. So it went from 3 to -3. So that answers part A. In part B, we want to do the similar analysis, but now we want to think about its point which is symmetric across the y-axis. And so remember that a point which is symmetric about the y-axis means we're now going to take this point P, which is at -2, 3, and now we're going to look at its reflection across the y-axis, which would put it over here at about 2, 3. And so we're going to look at its mirror image across the y-axis. So let's mark that point, the location of that point, in blue. So that winds up over here, and this has coordinates 2, 3. Okay, so we haven't changed the y-coordinate when we reflect across the y-axis, but we get x-coordinate which has the opposite sign. So now the point -2, 3 winds up at 2, 3. And in this case, we have the same y-coordinate, but the x-coordinate changes signs. Okay, in the last one, for part C, we now are going to reflect across the origin. So what it means to reflect the point across the origin is that we're going to take this point P, which starts at -2, 3, and reflect it over both axes. So for example, I can reflect it over the x-axis, which puts us at the point -2, -3, and then reflect it across the y-axis, which would put it down here in quadrant 4 at 2, -3. So let's mark the result of these two reflections in green. So here we wind up at point down here in quadrant 4, which is 2, -3. And so we started at -2, 3. We reflect across first the x-axis. That puts us at -2, -3, and then we reflect across the y-axis, which puts us at 2, -3. And in this case, we changed the signs of both coordinates. So here, the x-coordinate started at -2, and now it's 2. The y-coordinate was 3, and after this reflection across the origin, it now changes signs to -3. This would have been the same result, if you're wondering, as if we would have taken P, first reflected across the y-axis, and then reflected across the x-axis. We would wind up at the same point. So when we talk about the point which is symmetric about the origin, that means we reflect across both axes, and it doesn't matter the order which we do those reflections.